Welcome to the lecture series on convolutional neural networks. In this video, we look at automatic differentiation. In a previous video, we have calculated by hand the derivatives that come out of a convolutional layer with max pooling. But is this really what we want to do? Shall we really manually compute the gradients? Of course not. We should use automatic differentiation, also called reverse mode differentiation. The way it works is you record the computation tree on the forward path in order to apply the chain rule, and you apply the chain rule in reverse order on this computation path. In a way, it's the same idea as in standard BackProp used in normal feed-forward neural networks. Thus, an implementation of automatic differentiation just requires a tracker so as to record the computation tree in the forward path. And we also need analytical expressions of primitive operations, such as what's the derivative of x to the power of 3. Let's explain this idea with a simple example. So I have here a function which takes two entries, WA and WB, and WA appears here and there and there and there. Well, WB appears only once here at the end. Now, let's check how WA is connected to the output. Well, the output is this function G. And now WA enters 3 times. It goes directly into G. It goes into G via the function M. And then it also goes into G via the function K. Now, K goes into G via the function H, but H also uses WA directly. And then H goes into G, M goes into G. So we have these 4 locations for WA. Each of these locations is called a child. So we have these children of WA. K is one of these, M is one of these, H is one of these, but H is also a child of K. Now let's look. So I call this the forward calculation path. Now let's try to calculate the gradient with respect to this weight WA. Well, let's just apply the chain rule. You see that in any case, we have to apply a dg/dh This is where WA will appear, but G has actually 3 main entries. This H, this M, and this W that all depend on WA. So basically, we have to now go backwards. So dg/dh will be 1 entry. Then I have a dg/dm, and then I have a direct dependence dg/dwa. The gd/dh, well, it depends on the K, and it depends on the WA directly. So let's do this. DH, DK, DK, DWA, plus DH, WA, direct path. Then we have the DGDM, and the M depends on WA, and there's nothing in the other part. Now I said there's also this other variable. You see that it does not matter for this dependence. So the other variable comes in the same function g, but for this derivative with respect to WA, this does not matter. So now you see that we have a summation over many different terms, and the summations correspond to the different children that occur in the path. And while you use an algorithmic version, you have just to keep track that whatever you did in the forward path, you do also do correctly in the backward path, including the summations. Note that WA has 4 children, 1, 2, 3, 4, and these correspond to 4 terms within the summation. 1, 2, 3, 4. Of course, this also applies to this. Note also that none of the other terms, like H or K or M, have more than one child, so no additional summations are added. So, automatic differentiation, you first determine the children nodes of the weight variables, and then you need to find a backward schedule, a reverse ancestral schedule. So all children should be scheduled before the node itself. There's some freedom in the previous example, whether H is calculated before or after the K is it's a choice, it doesn't matter, but this condition that the children need to be scheduled before the node itself is important. Then if we do this chain rule application, basically means we start with a top node and run through the reverse schedule. We look up primitive operations, we define intermediate variables, we sum over the children and multiply, and then all this together gives the chain rule. Now this takes care automatically of max pooling, takes care of weight sharing. In other networks, it can also take care of recurrent connections, of lateral connections within the same layer. So this is the automatic differentiation procedures that are implemented in all standard software packages treating with neural networks.